Okay, here we are, 10.2, the last section of the book, ellipses and hyperbolas. Now I call this 10.2a because this is going to be a long video, so anyway, just warning you there, and I will make several. If you remember from 10.1, which in my world was about an hour ago when I made that, we had a formula for a circle that looked like this. All right, ellipses are basically, okay, this is a very technical mathematical term, so listen to this. There's a circle. An ellipse is a squish circle, is pretty much all it is. So the formula for an ellipse is going to be similar, yay, different. But the formula for an ellipse, let me see if I can find it here real quick, and then we'll go through what it all means. Let me hope I wrote the right letter. Looks like that. Okay, so not seeing a whole lot of similarities except an X and an A are together here, only they're divided. The Y and the B are together here, only they're divided. And so therefore, you know, when you're talking about an ellipse, let me get a graph up here. All right, so when we have an ellipse just like a circle, has a center point. So this A and this B, just like the A and B up here, are going to designate or tell you what the center point is. And we'll just go from there. Notice on this formula for an ellipse, this number here, this will always, always, always be 1. Okay? Whereas in a circle, it could be anything because it dealt with the radius. This does not have anything to do with the radius because, like you can see, an ellipse, the distance from here to here is 3, and the distance from here to here is more like 7. So there is no radius of an ellipse, but that 1 is an important piece of information. So here's the formula for an ellipse, and this is the formula for an ellipse that is centered at the origin, okay? So remember when we did a circle, it was just x squared plus y squared equals r squared. There was no a and b because the center was at the circle. Well, here we have an a and b, and we'll go into why we have an a and a b in a bit. So what this means here that we have is because our origin is in the center, the A and B have something to do with where the ellipse crosses the y-axis and where it crosses the x-axis. So it's almost like a radius for the x-axis and a radius for the b-axis, how far it is from the center point here and here, which will be the same, and from here to here, which will also be the same. So the center point of the where it crosses the x-axis will always be a 0 and negative a 0, because a has to be, this is going to be the same number because it's the same distance from the origin. So it's just over this way in the negative direction, this way in the positive direction. And because the a is underneath the x, it's along the x-axis, so that should make it easy. And then where it crosses the y-axis is going to be 0b and 0 negative b. So we're going to go left to right 0 and up b or down b from the center. So those are the 4 points that you need in order to find where it crosses the x and the y-axis. So therefore, if you've got your center point there and you know these 4 points, you can kind of get an idea of how to draw this ellipse here. Okay, so knowing that information, let's make that information small. Oops. Put it up here, and we can draw on it later. All right, so let's look at the first example they give us sketch the graph of 4x squared plus 9y squared equals 36. All right, let me put a graph in here because it does say that we're going to graph it. All right, so one of the things that you'll notice here, looking at this original one we have right here, I'm going to get rid of that, of the equation of a circle. That gets to be confusing there. One of the things that you'll notice is that there's a 36 here and there's a 1 here. All right, so that's the first thing we need to do is get rid of that 36. And the way you get rid of that 36 is you divide each term by 36, and 36 over 36 is 1. So we have 4x squared over 36. Yay, we have a 1. Now we can look at our fractions that we have here, and we can reduce those. Just makes it a lot easier. So when we reduce, 4 over 36 is the same as 1 over 9. 9 over 36 is the same as 1 over 4. And that equals 1. So now we have it in the formula that we need to have it in, just like this, in order to find our 4 points. Now we know we're centered on the origin, so that's going to make that point right there. Now all we have to do is, look at the original. The original one says that this number is a squared. It's the distance from the origin to where the ellipse crosses, but it's squared, a squared. So we're going to have to look at this and say, okay, this is a squared. So what number times itself gives me 9? So that would be 3. Same with the 4. What number times itself is 4? And that would be 2. All right, so looking at this here, these points here, my A is 3, so I've got a 3, 0, and negative 3, 0. My B is 2, so 0, 2, 0, negative 2. So all I have to do is graph those 4 points. So let's use red ink here. So I've got a 3, a positive and negative 3, and a positive and negative 2. That's just enough points to make a real nasty looking ellipse. Okay? So, again, just real quick. If you have a number on the right-hand side, you divide each term by that number. You reduce your fractions if possible, and you come up with the equation of the ellipse. This is the equation of an ellipse if it's centered at the center point or at the origin of the graph. Later on, we'll do some that are not centered there, but right now, let's just do that. We take the square root of that term, square root of that term, and that gives us our plus or minus, so we know where along the axis we are. Now, if I were to flip this around, if I were to have the y squared first and the x squared second, this ellipse would be a little bit different. It would have the same information, it just would be flipped over like this. So it would be up and down rather than from left to right. That's really the only difference that we would have there as far as where it goes. Okay, so next section has to do with what are called hyperbolas. So let me scribble on here what a hyperbola looks like, and we will go from there. All right, hyperbola basically is like this. So kind of a ellipse cut in half and flipped over, or it could look like this. Okay, the difference between a hyperbola and a parabola is just one piece that looks like that. The hyperbola has 2. And there is, a vertex there, and we'll get into how to draw these, how to put these together in this section. There's actually 4 sections to this chapter. One is the ellipse that we just did. The next one is the hyperbola. Both of these with the origins at the center. And then parts 3 and 4 are going to be the same thing, the ellipse and the hyperbola with the center point somewhere else on the graph. So hyperbolas with the center point at the circle. All right, one of the things, really the only difference between the formula for a hyperbola and the formula for an ellipse is the hyperbola has a negative sign instead of an addition sign right here. So the ellipse has a plus sign, the hyperbola has a minus. All right, so let's look at this and see what we're going to do. Let me give you an equation. And it also has to have a 1 at the end. So these are again centered, or the origin is at the center. Doesn't look like a 2. That doesn't look like a 2 either. All right, 2 OCD. There we go. All right, so just to kind of explain what's going on here, I'm just going to draw a real crude hyperbola of this equation. These are supposed to be exactly the same, mirrored across the y-axis, but not very good at it. All right, so look what we've got here. If we want to find out where this hyperbola crosses the x-axis, all we have to do is put a 0 in for this. Because where it crosses is at -3, 0. So that means y must have been 0. Or 3, 0. And the reason we have 2 here is because we have a squared. So let's put a 0 in for that and see what we get. Whoops, that's a 1. So x squared over 9 minus 0 squared over 4 equals 1. Anytime you have 0 in the numerator, that is 0. So we have x squared over 9 equals 1. If we want to find x squared equals 1 times 9. X squared equals 9. X equals the square root of 9 plus or minus x equals plus or minus 3. And that's where the -3 comes from and the +3 comes from. So that gives us the x-intercept. If we wanted to find the y-intercept, we would put 0 in here, and then we would find where it crosses the y-axis. But in this case, it doesn't cross the y-axis, so it doesn't do us any good. And you may ask, okay, if we don't have the graph, how do we know it doesn't cross the y-axis? What if we put 0 in for x squared to find out where it crossed y? Okay, glad you asked. Let's do that. X squared over 9 minus y squared over 4 equals 1. Whoop, equals 1. So we're going to put 0 in here. Okay, so that doesn't count. That's 0. Okay, so we're going to multiply both sides by 4. 1 times 4, or we can just write it as 4. Okay, now we're going to distribute this negative here, so it's a positive y. Because that's squared, we're going to take the square root of both sides, and we get y equals plus or minus the square root of -4. There's my problem. The square root of -4 is an imaginary number. It would actually equal plus or minus I times the square root of 4, which is 2. So we'll write it as plus or minus 2i. Whenever you have an imaginary number, that means it does not cross the y-axis. There is no answer. If it's imaginary, it's pretend. So that tells me that it doesn't cross the y-axis. So in case you needed some proof as far as how I know, well, you can put the 0 in there and find out for yourself if you wanted to do that. So at this point, all I have told you is where this guy crosses the x-axis. So what I have here, in fact, let me erase this. Let's say we wanted to graph that. Well, we know that it crosses the x-axis at 3, and negative 3. Well, that doesn't mean I can draw this because I don't know if it looks like this or like this. I don't know what the graph looks like. All I know is that it crosses the x-axis at those two places. Okay, so what I'm going to do here is I'm going to look at the number associated with the x squared, which is a 9. So we said it was a plus or minus 3. Okay, then I'm going to look at this number that's associated with the y, which is plus or minus 2. So I'm going to put a 2 here and a 2 here. All right, now I'm going to draw a rectangle. Okay, now I'm going to connect the opposite ends of my rectangle. Okay, so kind of fun to do that. All right, now I'm going to draw my hyperbola. I know it crosses there, so I'm going to draw that and draw that. So the black there is my hyperbola. These two lines, these two red lines tell me that my hyperbola, it doesn't matter how far I go, it's going to get closer and closer to this red line, but it will never cross it. Those are called asymptotes. Talked about that earlier. It's where the line does not cross. So by drawing this box here and then drawing a line through the opposite corners, I get my asymptotes. I have my point here, draw that, and there we are, good to go. So all I really needed here was the square root of that, square root of that. The square root of 4 is under the y, so I know it's this way. Square root of 9, 3, I know it's this way because it's under the x. That allows you to make a nice pretty drawing, okay? So that is a real quick and easy way to draw these hyperbolas given the equation once it's in this form. So remember, we have to get it in this form in order to draw the hyperbola. So that's going to be the part that gets a little tricky, is taking something that isn't in this form and putting it in that form. All right, this is example 2. Notice we have a y here and an x here. We have them different. So rather than it going this way when the x is first, it's going to go this way when the y is first. So it'll end up doing it by itself that way, but just so you don't even have to remember that, but just something to know. Okay, so all we're going to do, since it's already in the correct form, we're going to take the square root of 9, square root of 16, graph them up here. And this is a key part. The y is plus or minus 3. The x is plus or minus 4. So y is plus or minus 3. X is plus or minus 4. I'll do it in blue. Draw the box. Draw the red lines. Okay. And I end up drawing my cool little hyperbola going through that point there on the y-axis, going through that point there on the y-axis, and I'm done. All right, so let's end this and start the next video.